Once upon a time, I had this insane dream.
Where the hell are we?
I think we're trapped in the game, Mario Maker.
What's happening?
We're being merged together.
Whoa, what? Mario Maker with memes? I must be tripping. And then, it hit me. Oh my god! No way! I know what I must do. And just like that, my journey to develop a level builder meme game had begun. What you're about to witness is the mind-boggling story of how I made a level builder from scratch, with things like the custom 2D terrain builder, the publishing mechanism to share your level worldwide, the anti-cheating traps to catch hackers, and the ingenious leaderboard system. Oh, there is so much cool shit I'm about to show you. Ready? So where do you start after suddenly having a crazy dream to make a giant level builder game? Level builder game. Game. Gameplay! So I made a few simple enemies, weapons, a floor to walk over, Memorang Man, the main character you play as, text, sound, etc, just as a foundation to get up and running. But the level builder itself, I had to narrow it down somehow. So let's start small. I thought to myself, what's the first thing every level builder needs? How about a way of adding items to the level? So, I began work on this menu for the player to quickly be able to find any item in just a few seconds from the thousands of items that might be in the game. And to do this, the menu would need to give the player a way to filter through and organize all those items. And for that, we'd need to use SQL. SQL! It is you! Oh, you don't know what SQL is?
SQL, a programming language for downloading data from a database in the exact format that caters to you. Hell yeah. Filter and sort your data today. For a limited time only, terms and conditions apply.
Ah, very interesting. What if I were to pretend like all the items in my level builder are a database? Then I could just use SQL to filter and sort through all those items. So I did exactly that. Well, almost. I actually used C#'s equivalent of SQL, because C# is the coding language used in Unity. Using SQL then allowed me to create this UI in the menu, which lets the player filter through items by, say, the date the meme was most popular, or maybe filter by the meme category, or even sort the items newest to oldest. Okay, cool, but this just isn't good enough. We said the player has to find items in a matter of seconds, not scroll and scroll for frickin' eons. So the only logical next step was to add a search box for the player to type in the name of the item they're looking for, and then show results that match that search term as best as possible, just like Google. This kind of searching is a best effort approximation known as fuzzy search. What's that? You want me to show you how I implemented Google in my game? There was no way in hell I knew how to code a fuzzy search algorithm on my own. So, what I had to do was... and then... our code. And just like that, I now had a working search system for the level builder. Okay, so now the player can decide what items they want to add to their level. They click the item in the menu, and bam, it spawns the item in the level. But the next question is, how? How should the items be positioned in the level? What angle should they be at? How big should they be? And that's where I introduce you to the item placer. Oh dear, the item placer. This thing wasted so many months of my precious life because A, I'm not good enough at maths to know all the dodgy matrix calculations for all the transformations, scaling, rotations and whatnot. And B, Unity can really be a little piss stain sometimes. Okay, I say this, but actually Unity contains a lot of built-in matrix maths that I was able to leverage using some clever hacks without much understanding. So it only took me months rather than years to code the item placer. How does it work? When the player clicks an item that's already been placed in the level, this item placer appears around it. What's happening behind the scenes is that the item becomes a child of this new item placer, so now the child does whatever the parent does. Oh, that's why I'm such a control freak. Oh.
Did I bloody say you can bloody speak?
Anyway, to allow the player to change the item's position, I simply detect a click and drag on the item placer to move it around. Nice. Next, I needed a way for the player to resize the item. I created 4 emojis, one for each corner, so the player could click and drag to resize it. To calculate the new width and height of the item placer, I found the distance between the current mouse position and a fixed anchor point. As you can see, when I drag this emoji, both this one and this one move as well, but this emoji stays fixed. We found our perfect anchor point. Although, I'm not quite sure it's a good idea to allow this resizing to happen all the time. It might be ruining the player's experience. I'll come back to this later. And lastly, I needed to let the player rotate the item. After a lot of unnecessary pain, I devised a super simple way to do it. When the player drags this new emoji I just added, it forces the y-axis of the item placer to go through 2 points, the mouse position and the center of the item placer. And all I had to do was ask Unity nicely. I also made a delete button and a duplicate button to clone the selected item. You can even clone Memarang Man himself. I was even able to add 4-player local multiplayer on the same keyboard. There's also these buttons to change the sort order of items. As a final touch, I made this custom settings button so the player could configure certain items to their own specific settings. For example, the Mountain Dew pool's physics properties can be changed like this, I can increase ammunition a weapon has like this, and I can customize all the text on the level to basically whatever I want. It's also worth mentioning that for all this cool item placer stuff, I added touch controls such as pinch to zoom and rotate, so that Meme Game would work smoothly when I port it to iOS and Android. This looks awesome. But there's a little bit of an issue with the level builder. When I drag an item to the side of the screen, it gets cut off. In fact, right now, the player can only make a level at most be the size of their screen. That's absolutely tiny. You know what else is tiny? So, I upgraded the default camera using a script that lets the player click and drag the camera around, or use WASD. It zooms the camera in and out when you scroll the mouse, or pinch to zoom on mobile. As a final touch, for a nicer user experience, I made it detect when an item is being dragged to the side of the screen, and move the camera in that direction. Now that's what I call progress. Progress that the player won't have the mental space to enjoy, because right now, they'd be crying about how their entire level disappears into oblivion after they click the stop button in the Unity editor. Yep, I hadn't actually implemented a way to save the created level. Now let me explain to you a little something about us nerds. In the Hackerman world, we quite like assigning ridiculous words to very basic concepts. Let me explain to you one of those words. Serialization. No, you idiot, not that kind of serial. Sorry about that. Serialization basically means taking some data that's in your RAM and converting it to a format that can be written to a file on your hard drive or SSD. Yep, it's really that simple. So in hindsight, maybe that skit was a bit overkill. But yeah, serialization is what I'd need to use to save the level to a file. Currently, the entire level is stored in RAM as a C# class. The class has a list of all the items that the player has placed in their level. Now lucky for me, C# is a very popular programming language, and so there are already a bunch of pre-made serialization libraries out there for me to hippity-hoppity. You are now my property. Dude, stop! So I downloaded a serialization library called JSON.net, created by this dude, which would now automatically convert my C# level class into a JSON file. Well, actually, the file extension isn't .json, it's .meme, because I do as I please. Oh, and in case you were wondering, JSON files are basically just text files, but with a bunch of squiggly boys to structure the data nice and tidily. I use it a lot throughout my game, so keep this in mind for later. But regardless, my problems have now been solved. The level can now be saved. But that's only half the story, because now I'd also need a way to convert from the .meme file back into the C# class to load up the level again. Thing is, I didn't have a way to import the meme file into the game to test out this deserialization process, and at this point I just really couldn't be fucked. So I ended up buying this file explorer asset from the Unity asset store for $45. Not my finest hour. But look on the bright side, this file explorer worked so well that I actually decided to keep it in the game for good, instead of just using it for testing like I'd originally planned to. So now, players could share levels with each other directly, instead of using the whole online level sharing system, which I'll get to very soon. Right, so we still can't call what I've developed so far a level builder game, because there's no way to play test the level. That's like the main game loop. So I made an in-game play and stop button to enter and exit play mode. Then I did a big oopsie. I ended up wasting like 2 months of my life because, like a naive moron, I spent so long trying to optimize the code before I even knew if there would be any performance issues. Fucking stupid idiot. So what the optimization was, is when you exit play mode, it basically tries to manually reset each individual item in the level, rather than reloading the whole entire level from scratch. This worked fine in the early days when there wasn't much gameplay, but the more hype shit I coded into the game, the more properties I found myself having to manually reset, and eventually, it just got way too much to keep up with. So I went on an inspirational journey that gave me a realization I ought to have had many many years ago. On exiting play mode, why not just delete all the items in the level and then recreate the level from the serialized.meme file? I mean, I had already coded the whole deserialization mechanism from before, so it's free money. And it worked perfectly. It made no noticeable difference in performance whatsoever. Fellas, learn from my mistakes. Don't optimize prematurely. But guess what? We're now at the stage where we can call it a level builder game. Yes, it's currently a steaming pile of wank, but there is a fully working end-to-end level builder system. And boy, do I hope you like capsaicin, because I'm about to crank up the spice levels a notch. Starting off with the 2D terrain builder. One day, lil old me was perusing the Unity package manager when I noticed something out of the corner of my eye. What's this? 2D sprite shape? Sprite Shape Runtime and Editor package contains the tooling and runtime component that allows you to create very organic looking spline-based 2D worlds. Blah 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 blah. Wait, what? It's a runtime package? I can modify the 2D spline while playing my game? Now I know feature creep is the root of all evil, but this... I mean, I couldn't say no to this kind of a thing, you know, it's just, look at it, it's beautiful. I played around with the package, and it seemed to be really intuitive to use. There are these control points along the spline that I can move around like so, and then these tangent handles that stick out from each control point that do this. I can add control points by clicking on the line, and can even set the height of each control point using this slider in the Unity Inspector. How cool is that? But it's not as easy as you might think, because all these awesome controls are only meant to be used in the Unity editor. They don't actually work while you're in-game. The only way to change the 2D spline in-game is through code, and lo and behold, this code is not documented properly anywhere, so I had to figure it all out through trial and error, and this took me months. But eventually I was able to make my own awesome custom controls with some extra
Pizzazz.
See here, now you can change the height directly from the control point. Now I don't know about you guys, but this control point is looking kinda thick. Alright, I think I've described the process of creating a level pretty well now. It's time for things to get juicy, because now I'm moving on to the online level sharing system. We've got cloud computing, cheat detection, hyperspeed databases, anti-hacker mechanisms, goddamn leaderboards, and so much more. So turn off your phones, finish your conversations, and get ready. It's about to begin. So you finished building your level. Now you want other people to play and judge your level. You go to that shiny publish button, and just hold it right there. You haven't proved to me that you can actually beat your level, so I'd need to implement some sort of verification system for the player to prove their level is winnable. Now, I could have just had a flag that gets set to true when the player wins, but I thought that would be kind of a joke for hackers. So I thought a better way to go about it is when the player wins, save a copy of the level, and then when they click the publish button, make sure that copy is equal to the current version of the level. That way, we stop the player sneakily modifying their level between them winning and them trying to publish. Funnily enough, I found that JSON.NET was the perfect solution for comparing the two level versions with each other, because I could just utilize some inbuilt functions that check the equivalence of the serialized levels for me. Cool, so now the player is allowed to upload and share their level with the world. Now I'd need to figure out how to build the level sharing network. In this day and age, it's pretty darn stupid to try and host your own server. It's just way too much effort. The more sensible approach would be to use a cloud service like Amazon Web Services, Google Cloud Platform, or Microsoft Azure. They do all the heavy lifting for you, and offer some pretty yummy guarantees that everything will run nice and smoothly, assuming you don't bombard your provisioned resources to shit with gazillions of network requests. So I scoured the web for the best cloud gaming service I could find, and narrowed it down to two options, GameSparks by AWS, and PlayFab by Microsoft Azure. Now normally I'd have slagged Microsoft the f*** right off, seeing they've caused me so much pain in my life. But when I visited Amazon GameSpark's website, I was mortified. I was morbing. It looked like an absolute graveyard, and honestly, I got the impression that no one had maintained the thing for years. Just look at this forum post. There have been no SDK updates in ages. There is no support, this forum is dead, and there has been no communication from GameSparks pretty much since Amazon acquired them. So against all odds, I decided on Microsoft PlayFab, and luckily, because Microsoft is the creator of the C# programming language, they had made a pretty decent software development kit for Unity, so that was a lucky break. But how exactly was I planning to use PlayFab in my game? Well, PlayFab has these three things I needed: manage player accounts with email and password authentication, run custom server code via Azure Functions, and support file uploading directly from the player's device. You starting to see why this could be so useful? When the logged in player clicks the publish button, the .meme level file gets uploaded directly to PlayFab. Then, once that completes, an Azure function I'd coded transfers that file from PlayFab to Azure Blob storage, where the level file can be hosted permanently, and more importantly, can be downloaded millions of times by other players around the world. There's something missing though. How will players around the world be able to find these published levels? What, you think their computer is just going to download every single file and filter through them on their end? Do I look like I'm made of money? Obviously not. I'd need to keep track of these files in a database. Then I could send to the player only the files they needed to download. Much more efficient. Do you remember SQL from earlier? Yeah, well, fuck that. We live in a society, we have technology, we have no SQL databases. Instead of using glorified Excel spreadsheets like SQL does, NoSQL typically stores data as JSON documents inside a collection. Much easier to use, much more scalable, and much faster. Perfect for my level builder ecosystem, which could have potentially hundreds of thousands, if not millions of levels that need to be queried in a matter of milliseconds. At first, it would probably make sense to go with Microsoft's own NoSQL database, Cosmos DB, since I'm already using Microsoft Azure. But then this happened. Huh, Cosmos DB looks pretty cool. Huh? What's this? You need a partition key to use Cosmos DB. It is a very confusing concept and we contradict ourselves trying to explain it. What? Bruh, what the fuck? Not today, Microsoft. Not today. So I turned to Firestore. Good old Firestore. A ridiculously fast yet simple database made by Google. On the one hand, it's super limited and will force you to query your data in very particular ways. But on the other hand, because of these limitations, it allows for guaranteed hyperspeed just by the mathematical nature of these limitations. But at the end of the day, it was just way easier than stressing out over a stupid partition key. And of course, as with any mechanism that allows a user to upload files, I coded some basic but highly necessary security checks to prevent hackers doing their thing. For example, I don't let the level file be more than 10 megabytes, and I limit the number of levels an authenticated user can publish to 1000. Pretty litty, bro. So now the player can publish their level to the internet webs. But at the end of the day, who cares about that if no one has a good way to actually find those levels? This leads me on to the level browser. I wanted the player to be able to browse through levels sorted by either newest to oldest, most to least popular, highest to lowest rating, or lowest to highest clear rate. I also wanted them to be able to filter by how new the level is, cause no one cares about irrelevant shit. And lastly, I wanted a filter for levels with experimental features set to disabled, which is for players who can't be asked to play levels with crazy freeform scaling and other random shenanigans I didn't want to explicitly support. Great, so I'll just model these filters as a Firestore query, and all will be well and grand. Until I stumbled upon this in the Firestore documentation. If you include a filter with a range comparison, your first ordering must be on the same field. Shit. So I can't sort by most popular, and also filter levels published within the last week. Oh, I knew I shouldn't have gone with Firestore. I knew its limitations would come back to bite me in the ass at some point. What do I do now? Rethan, it is I, the fairy of engineering mindset. Just bloody Phew. Oh, jeez. Oh, hold on. I don't actually need perfect accuracy in order to filter by how new the level is. I just need it to be roughly correct. Screw that pesky greater than filter in the query. Wahoo! So my solution was to add these extra fields to the level document. Day published, week published, month published, and year published. These fields are just the values you'd expect, but converted from number format to text format. For example, day published might look like this. Now when I build the query, instead of checking if the date published is greater than some value, I could use Firestore's wherein query, which basically lets me say, find me all documents where the day published text is in this list of values. So for example, if we create a recent filtering option for the player to select, it would find documents where the day published is in the list today, today minus 1 day, today minus 2 days, up until today minus 9 days. Same thing happens if we give the player a long-term filter. It checks if the month published is in this month minus 1 month, this month minus 2 months, up to this month minus 4 months. Now I could combine this wherein filter with a sort order on any field I want. Sick! The query now fully works for the level browser. So to filter levels by how new they are, the player now gets these options instead of the super accurate ones that were so hard to implement. It is now time to fight the final boss of my level builder journey, leaderboards. Something I had to insist on having in the game. Without them, there wouldn't be any sense of competition with other players. That's not very fun. So I was willing to go the extra mile to get a high score and best time leaderboard working for every single level that gets published. And boy, did I have to go the extra mile. But why did you? Surely it's not that hard. It's just a list of users with their score and ranking, right? Can't you just use like a database and keep an entry for each score in that database? What, and download the whole database whenever a player views a leaderboard? There could be hundreds of thousands, if not millions of leaderboard entries, and that would eat through my quota instantly and make me homeless. Okay, but you don't need to get all the entries at once. You only need to get entries in pages of 20 or 30 at a time while the player scrolls through the leaderboard. Yeah, that would work nicely if you're scrolling through the leaderboard in order from top to bottom. But now you have to load the leaderboard in order. You won't be able to just instantly jump to any position in the leaderboard to check it out. And more importantly, you won't be able to instantly jump to your position in the leaderboard and see who's above and below you. Okay, so just have a button to jump to the page where your score is. You can write a query to get entries whose score is around your score. Yes, that would work, but then how's it gonna know what number ranking you are in the world if it hasn't loaded the entries above? Isn't like the whole point of a leaderboard to see what number in the world you are? Okay, then just add a field in each entry to store the rank and display that to the player. Say I do that. Now say someone comes along and beats the world record score for a level with 1 million leaderboard entries. Now I have to go through and update every single existing entry's rank to be one lower, and that too would make me homeless. Fine, don't store the rank. Just calculate how many entries there are with a score higher than your score, and that will equal your ranking. You think that's any cheaper? It'd still need to go through every entry. It can't just magically know how many there are. If you're at the bottom of a leaderboard with, say, 1 million entries, that's 999,999 entries to go through. Homeless. Probably even have to sell my left kidney. Okay, I see where you're coming from. It seems hard to implement leaderboards on your own from scratch, but surely there are tons of cloud services out there that do leaderboard systems for you. It's such a commonly used thing. Yeah, but these leaderboard cloud services are designed for normal people whose games have a small, predefined number of leaderboards. Not crackheads like myself, who made a level builder game which could have hundreds of thousands, if not millions of leaderboards. PlayFab itself only supports up to 300 leaderboards, so yeah, I'd have to make it myself. Okay, so how about we say screw databases? Who said you even need to use a database? Why not just store the leaderboard entries in like a JSON file? Then the client can download that file when they want to see the leaderboards, and then you can jump to any position instantly. Okay, you're onto something. But think about updating that file with a new entry every single time a player wins a level. The server would have to download the whole leaderboard file, update the file, then write it back to blob storage. Every single time a player wins a level. So yeah, I would have to sell my left kidney and start shotting food. This is so annoying. Why will nothing I think of work? Wait a minute, the issue with the JSON file idea is about writing to the leaderboard data, not reading. And the issue with the database idea is reading the data, not writing it. So why not combine the two? And all our problems will be solved. Oh, you cheeky bugger, you. Genius. So that's exactly what I did. When a player wins a level, a new entry with that score still gets written to Firestore database. Then, instead of also writing that entry straight away to a JSON file, we use a cron job. A cron job is just a way of scheduling a task to run every so often, which luckily PlayFab has built-in support for. So I created an Azure function that runs every hour to go through the entire Firestore database, find all dirty leaderboard entries that haven't yet been written to the respective leaderboard file, and then write all those entries in one go. And this seemed to be the solution I'd needed all along. Now leaderboards work perfectly, my bed stays warm, and my bladder stays empty. I just pissed myself with horror having realised cheaters could hack their way to the top of the leaderboard. Honestly, cheaters are just sad people looking to ruin the fun of so many others. So naturally, a big part to leaderboards should be cheat prevention. While at the end of the day, cheating is almost near impossible to actually prevent against. You can make life pretty darn hard for cheaters, mostly by doing special checks on the server. So there are two main things I did to try and detect cheating. The first is checking to see if the score is realistic for the given level. I download the level file from blob storage to the server, and then calculate what the maximum possible score could have been for that level. Then, if the score that the player got is bigger than this, well, I know they're cheating. The second thing I do to detect cheating is I compare the level just played with the source of truth level in blob storage and make sure they're equivalent. When the player wins a level, that level is uploaded from their device's RAM to the server, where we do this check for equivalence to make sure the level hasn't been tampered with. And if the player gets caught cheating, banned. Well, not really. I actually commented out that line of code because I'm nice and will give you the benefit of the doubt for now. But if you start abusing me and my system, All Boss Man has to do is place mouse cursor over line 101 of updatelevel.cs, hit command / and ravioli, the ban system is now back in place. So don't tempt me. But yeah, I reckon this cheat prevention system is pretty decent. But still, please don't try and hack me. I am providing you with a useful service. Right, so that's the meat and potatoes of my level builder game. I tried to explain everything as if you're a game dev noob. I didn't want to get too nerdy because I need views, although I really wanted to. I also skipped out a bunch of cool things because there wasn't enough time. For example, did you know that players can take other players' published levels, edit them, and re-upload them as their own? And the original creator still gets credit. You can see the chain of credit in the level info page. You can also go to a player's profile to see the levels they played and published, and the total likes, dislikes, and plays their published levels have received. And if you just want to play the game, well, I'm actually planning to release the game early access on Steam when I hit 10k subscribers. Just subscribe to my channel. You can show your appreciation by hitting that thumbs up button and sharing the video. God, I love being a nerd.